Hello adventurer, welcome to ScratchQuest. Today is day 2 of C programming intake from Zero series, and today we'll be learning about programming overview. Before we start learning about how to code in C, I want to know you about the programming overview. Programming overview is basically learning how a professional or a company really makes a software. I'm learning this programming overview so that we get overview on how a company really does stuff. Now let's learn. There are basically very different stuff or steps of programming and making a software. Let's say you work in a company called IHO. In this company specialization in making software for clients. Now you are assigned to a person named Rons who have a restaurant in US, Minnesota, and he wants to make a software where a customer can order stuff and leave a review. That's what runs one. And we as a programmer have to build the software for it runs. Now, how we do we make a software? Do we start typing the code right away? Obviously, no. We need to go from step to step to build a software or a successful software for us. So let's start. The first step is user requirement. User requirement is basically asking what the user wants. So for example, Ron wants to build a restaurant where people can order and leave a review. But how would we know what Ron's want without asking Ron's? That's why user requirement is needed. We must ask what he wants, what he doesn't want, what he wants to include, how does his restaurants or wants to be looked, how what theme he wants, what links he wants, how do he plans to really advertise this plan. We take all this consideration by asking the user or asking the client what he wants. This is the first step. We ask him, okay, this is are the stuff you want, right? But then comes the second step, feasibility. We cannot always fulfill what user wants because there are certain restrictions. Feasibility means checking whether a project or a software we are building is possible, practical with available time, money, technology, and resources. So, as you once have provided, told us that he wants to build a app where customer can order stuff and leave a review, and we have a budget of $1,000. We as a programmer have to see with the given budget and with the given time we can do the stuff he wants. Or for example, let's say he wants to build an app where it shows different menus. It shows the possible combination of dishes, which is generated right away. But with given the money and the tech we have, we cannot do all this stuff. That is feasibility. We programmer must check if the given user requirement is possible with our time, money, technology, and say to the user, these are the stuff which are off the limit or off the budget, and you need to change the user requirement. That's why second step feasibility is needed. This type of feasibility are technical feasibility, economical feasibility, time feasibility, operational feasibility, and legal feasibility. So in hence we have to check if the given project is technologically possible, economically possible, is possible within the given time, it is operationally possible, and if it is legal or not. The programmer must check that Let's go to our third step, that is design. Now, as we have discussed the user requirement and see if the user requirement is feasible or not, rather than jumping right into coding and making program, we need a plan. For a coder, design is like a plan. Plan is essential as it shows path on what to do, helping us increase our productivity. And we use the design tools to make a plan so that we coders can understand what to do next. Without plan, coding is really hard. So we need a design tools to build a plan so that we can increase the productivity of coding. So what are these design tools which helps us to increase our productivity and make a plan? Let's see. First of all is algorithm. You must have heard this somewhere, right? Algorithm is a step by step of instruction written in simple human language that helps us to solve a specific problem. Let's see. As we were building a restaurant for a run, let's see how we can make a plan using the algorithm for it. So first of all, we start coding. Then we read menu. Sorry. Second of all, the second step is make sure the user orders. Then after user orders, user reviews, then it is displayed. And 5, stop. This is not the right way of making algorithm, but overview of making you know that what algorithm really is. It's a step-by-step instruction of coding, but a very in simple way. For example, let's say I'm adding a two number. In algorithm, what we do is, right, let's say we first say start, then read two number, then add the two number, display the number or the result, and 5, stop. This is a very basic human language which is used in very complex like stuff so that a coder can understand what the coding is really about and what to do. When we see bunch of code, it is really confusing to decipher what the code is really telling, but using the algorithm or writing first what need to do using algorithm, it makes coding easier. We first start, then after we see read to number, we write the code. First of all, we write the code which is a to number, then we add the number in the code, then it is displayed. We see the step by step in algorithm which helps us to understand how to code. Similarly, another way of doing this is pseudocode. Pseudocode is similar to algorithm but a little bit hard. It is similar, but rather than that, human language is closer to a programming language. So read a b, yes, is equal to a plus b, display, yes. So it is closer to a programming language than human language, but still understandable. Then comes the very interesting thing, that is flowchart. Up to now we were just writing, but flowchart is a visual representation of algorithm. Before we were writing what to do step by step. Now we in flowchart we just visualize what was written but in flowchart. So there are different shapes and sizes which helps to make a flowchart. In flowchart, a oval shape is used to indicate a start and an end. Rectangle is held to show it is being processed. Parallelogram helps to show input and output. Diamond shape is used to show decision. I will tell you how flowchart is really done very simply. Let's see the example we did, adding to two number. In the algorithm we write start, add to input, input to number, add to number, and give the result. In flowchart, rather than writing, we make it using the diagram. First of all, start. As we have said, start is represented by oval sign. Then comes the arrow sign. Arrow tells us where to go. After start, we want user to enter the number, so we make a parallelogram. Parallelogram tells gives us input and output. So we first ask to read, or sorry, to input read A and B, or two number. Then after inputting, the process happens inside the rectangle. So A plus B. It is like a process on what really happens. This specification is in here. So after A plus B, after process, we need to display it. To display again, we use the parallelogram. So display is equal to A plus B, and the end is again used to show by oval. Now we can also use diamond to show, use if else, and so use decision. For example, if A is bigger than B, yes, A is greater, no, B is greater. This is just a very simple example of how our diamond is used in flowchart to show the decision tree. This is an overview of how flowchart is really made. When there is a very huge program written, flowchart is very used so that a programmer gets overview on what to do next, step by step, making the programming easier. This is the design tools. There are other design tools like DFD, context diagram, which we'll be reading after a few days. But these flowcharts and algorithm are the very building blocks of making a plan. After we make a plan, then we start coding. We see what user wants. After we see the user wants, we make a plan according to that. We see the plan and start coding. I don't have to explain much about coding. This is just writing the code. But after writing the code, we just don't automatically like post what we have coded and make a software and give it to the user. No, we first need to test whether or not the code is right or wrong, if it is according to the user requirement, and if there is any error or any box, we debug that. So debugging. The fourth step is testing and debugging. Only after testing if the code is working or not and if it's the user requirement, every solve, then we come to the next part, that is implementation. Implementation is giving the software or the app to the user. After implementation, still in many cases, there are bugs and stuff like that. So that's why we need to evaluate. We have to evaluate whether or not our code is working fine or not, if there is any error. And sometimes we need to be, we have to maintain the code so that there is no error. If there is error, we have to maintain that. So then the sixth place is evaluation and maintenance. After all this is documentation. The program is working well, we have maintained if there is any error coming up. After that, it is documentation. Documentation is written useful information about software which helps both users and future developers understand system quickly. It is like telling, okay, this was our plan, this is what we have made, and this is the thing we need to do in the program. So it is like user there are two type of documentation. There are user manual and programming is basically software tells the other coders that what the program is. User manual is telling the user how to use the app. So the step-by-step process of building a software is first of all user requirement, feasibility, and analysis. Then comes design, designing what needs to be done next, what to not. After design is only is coding, then is testing and debugging, then is implementation, and sixth is maintenance is evaluation and maintenance, and seventh lastly is documentation. Now these are the steps to make a software, but in a company or a person have different way of taking step by step. Some people basically go from top to down or stuff like that, but there are various ways of step process of making a coding, or there are various kind of making a software, that is called a module. There are few different modules. There are waterfall module, spiral module, agile module, and more. You may be confused on what these are, but as we must understand this. First, we have discussed about the steps of way of software is made. Not every company follows this process. Some uses some method, some uses other method, and some of the popular method of the module are first of all the waterfall model, spiral method, and agile model. So this module is a plan that tells us what to do, but there are different ways to make a plan. So that is overview of plan. Let's just understand with the waterfall model. Waterfall model, as it suggests, is like a waterfall. It goes from top to down. A waterfall never goes from bottom to top. So we first take user requirement, software design, implementation, testing, and maintenance. So it is basically waterfall model is basically the step we have discussed. But once we do one step, we cannot go back. So after we take the user requirement and take the feasibility, and we go to making design, and user wants to change something, and user wants to we need to, again, we cannot go back to user requirement. After designing, after coding, we cannot go back. After implementation, we cannot go back to user requirement. So waterfall model is a model where after one step is done, it cannot go back to another step. It can only go from top to the bottom. So data requirement can only go to systems of a design. Cannot go back to data requirement. Implementation and unit testing cannot go back to system and software design. It can only go down. Now waterfall model is rarely used nowadays, and it is used for a very low budget project, and a project which needs to be finished really quickly. Now spiral model is just opposite of the waterfall model. Rather than just going from top to down, if there is any like a thing that the user wants to change, the user can change. The waterfall model, spiral waterfall model looks like this, where it goes from top to bottom, and the spiral model is like a spiral. It goes in a loop. If a user don't like something, it can change, but only after it finishes the loop. So once we take the user requirement and we make a design, we just cannot go from user design back to the user requirement. We first have to complete the loop of coding, implementation, then after only finally making that, we go back to the user requirement. So after user requirement is taken, and we make a design, then we code. Let's say user want something to change, we cannot go directly back to the user requirement or the design. We first have to implement that and maintain that. After all these steps are finished, it is run in the loop. So start from the very top. It is like a loop. We cannot go directly from one to another, but it had to go in a loop. Then comes the agile model. Agile model is one of the most used model in the modern software developing uh, market. As a model is built as you go approach to the problem. Instead of planning everything upfront and delivering one final product months later, usually break your work into smaller pieces, usually 2 week cycle, and improve it as you go. So it is taking user from the very top bottom and working with the user. So we ask the user the requirement rather than going right away and building the software. We make a beta version of the code. So we design it, make a code for it, and see if user is satisfied. If it is not, we go to step one. If after user is satisfied, we go to next step again. If user is not satisfied, we again go to next step. So this is a matter where programmer needs to be constant connection with the user, and user gives us constant feedback on what he wants to do. So the agile model three-step logic is plan and build, review, and adjust. These are the steps. So codes until the user is fully satisfied. This approach is very used, but a very expensive one. Uh, it needs constant talk with the user, and it is expensive. So these are the sums of that company uses when building a software, and I wanted you to learn about this. There are many other soft like DFD, context diagram. There are different approaches of programming like modular approach, top-down approach, object-oriented approach. These are the stuff that we need to also learn as having a knowledge of how programming really works, but we don't have to go that deep. Let's keep this much on this much for now. In the next day we'll be learning about the very basic of C programming. Let's have overview of what we learned today. We learned that we cannot directly code right away. We need to make a step-by-step process of how to code, and we learn how a company really codes. We learned that all start with asking the user what he wants, then checking if we can do that what user have want. Then if we checking okay we can do that, we start building, we can start coding. We check, we test the code, we implement, then debug it, we check the code, we debug it, we check the code, we debug it, we implement it after checking all the things are correct. Then after implementation we check if it is, we evaluate the soft, we evaluate if our code is right or wrong. After evaluation we maintain the code to make sure there is no error. Then after maintenance, at last we document all this stuff to make sure that user know what to do in the software, and a coder knows what the code is really about. So these steps basically is overview of how a software is really made in a company, or a person really how person really makes a software. I hope you understand this. I decided to learn about this first as if we an overview of how code is really written. So we as programmer, as we learn C programming, we can know that. So yeah, I hope you understand what I mean to say. If there is any confusion, please drop in comment. I'm learning with you. I know there is a lot of mistakes, pronunciation mistakes, yeah, knowledge mistakes, but I hope to like improve this as we go on. So yeah, hope to meet you in next video. Bye bye.